Welcome to the next session of ANSYS APDL. In this session, we will be solving a cantilever beam which is subjected to uniformly varying load. You can see here, this is a cantilever beam which I have shown here. For cantilever, one end will be fixed and the other end will be free. So I am going to use this end over here, as you can see, as fixed, wherein the load is 0, and at the other end the load will be of 30 kilonewton per meter. Now we will start solving in ANSYS APDL. I'll first go to preferences. I'll choose structural. OK. Next I'll go to preprocessor, element type, add, edit, delete, add. I'll choose beam, 2 node. OK. Close. Then I'll go to material properties, material models. I'll choose structural, linear, elastic, isotropic. I'll assume the value of E as 2E5. That is, I'm assuming that the material is structural steel, and Poisson's ratio I'm assuming as 0.3. OK. Close. Next I'll go to sections, beam, common section. I'll give the width and the height as 10. Preview. I can see the cross section here. OK. If I don't want to see this anymore, I'll go to plot, replot. This completes section. Next I'll go to modeling, create, key points, inactive CS. Now the first node is always at 0, 0, 0. So even if I don't write, it's fine. Apply. Now the second key point, for this, the length is what I'm going to take into picture. You can see here the length I've assumed is 0.4 meter. That is, it is 400 mm. Okay. So I can see the two key points now. Next I'll go to lines, straight line. I'll choose the two key points that I have made. Okay, so this makes my beam. This completes my modeling. I'll now go to meshing, size control, manual size, lines, all lines. I'll choose number of element divisions as 4. Okay, so I can see 4 divisions here. Next I'll go to mesh, lines, pick all. So I can see the meshing has been done. So this completes the meshing portion. Now if I want to see the elements, I'll go to plot controls, numbering, element or attribute numbering. I'll change this to element number. Okay, so I can see the elements here very clearly. Now I'll apply the boundary conditions. So I'll go to loads, define loads, apply, structural. I'll first apply displacement on key points. On this first node over here, I'm going to apply fixed. So I'll write all degree of freedom. Your displacement value is nothing, which means it is 0. Okay. Next I want to apply UVL on this beam. So you can see here, this is the UVL that is applied from 0 to 30 kilonewton per meter. Now you can either apply the UVL by using a command, wherein you can write a code and you can give the UVL value. But here we are using another technique, wherein I am going to use this simple formula, that is 30 divided by W is equal to 0.4 divided by X. So this gives me the value of W at various values of X. Now each division is 0.1 meter. So for the first element, this X is 0.1. So when I substitute 0.1, I get this value of load as 7.5. For the second element, the value of division is 0.1 plus 0.1. So this will be 0.2. So when I substitute 0.2, this becomes 15. And so on and so forth. If you apply, you will get these values of load. So I'm going to apply these value of load on these elements. So I will start by applying pressure on beam. I'll choose the first portion of the beam. Okay. Now the load has to be applied along the y-axis. You can see here the axis is y. So I'll change this to 2. If you are applying in the x direction, write it as 1. So here I'm going to write the load key as 2, and there are 2 nodes, as you can see. That is, each element will have 2 nodes. So the first value is 0 and the second value is 7.5. Okay, so you can see here, this is the UVL applied on this much portion. Accordingly, I'm going to draw UVL on the other elements as well. So we'll continue on the second beam. Okay, this will remain to 2 and the value is now from 7.5 to 15. That is my second value. Apply. So you can see here. Next, I'm going to choose the third portion or the third element. Okay. Here I'll write it as 15 to 22.5. Apply. And the last portion now. Okay. This is 22.5 to 30. So this is an approximate way of applying the UVL. The results may not be accurate, but you will get precise answers and they are approximately correct. Now that's all about the load on this beam. I'll go to solutions now. Solve current LS. So solution is done. Now we can see the results. So I'll go to general post processing. I'll start with plot results. I'll go to deformed shape. I want to see the deformed and undeformed shape both. Okay, so now I can see here this upper portion is the initial beam, and on application of UVL I can see a deformation of this sort. Display of element when it is switched to on, you can see the 3D figure. If you want, you can see the isometric view here. And if you don't want to see it, you can go back to size and shape and switch off the display of element. Next, I'll go to contour plot, nodal solution. I want to see the degree of freedom, displacement sum vector. Okay, so here I can see the displacement at each node. Also, if I want to see the stress, I can use the same technique. I'll go to nodal solution, stress. I want to see the von Mises stress on the beam. So here is the von Mises stress. Now suppose if I want to list the results, I'll go to nodal solution, degree of freedom, displacement sum vector. Okay, so here I can get the listed values. You can see here there are 5 nodes, which means there are 4 elements. I can see the displacement along the x, y and z axis. That is the displacement obtained for each node. Next I'll go to elemental solution, stress, von Mises stress. Okay, so here I can see the values of stress on the beam. So this completes for a cantilever beam which is subjected to UVL. In the previous video, I have also shown you how to get the animated version. You can go to plot controls, animate, deform shape. We can see here deformed plus undeformed. Okay, so I can see the animation of this beam. If I want, I can just increase the speed so that it's a little faster. So with this, I'll end the session. I hope you have understood the procedure for solving for a cantilever beam which is subjected to uniformly varying load. If you have any doubts, please write to me in the comment section. See you in the next session. Thank you.